Have you ever looked up at the night sky and wondered where it all came from? How did the stars, planets, and galaxies come to be? The answer, according to the most widely accepted theory in cosmology, is the Big Bang. The Big Bang theory suggests that our universe began from an extremely hot, dense state about 13.8 billion years ago. It wasn't an explosion in the traditional sense like a firework going off in space. Instead, it was the rapid expansion of space itself, carrying all the energy and matter of the universe outward. Imagine a tiny balloon with dots drawn on it. As you inflate the balloon, the dots move further apart. This is similar to how galaxies are moving away from each other in our expanding universe. The Big Bang theory is supported by a wealth of observational evidence, which we will explore later. But first, let's journey back to the very beginning, to a point known as the singularity. At the heart of the Big Bang theory lies the concept of the singularity. Imagine all the matter and energy in the universe squeezed into an infinitesimally small point. This point, smaller than an atom, is the singularity. We can't fully comprehend the singularity with our current understanding of physics. The laws that govern the very large, like gravity, and the very small, like quantum mechanics, don't seem to work at this extreme scale. Think of it like trying to divide by zero on a calculator. You get an error message. Similarly, our current physics breaks down when we try to describe the singularity. However, we believe this point of unimaginable density and temperature existed for a fraction of a second before the universe began to expand. From the singularity, the universe expanded rapidly in a process called cosmic inflation. In an incredibly short amount of time, the universe grew exponentially, increasing in size by a factor of at least 10 to the power of 26. That's a 1 followed by 26 zeros. This rapid expansion is thought to have smoothed out the early universe, explaining why it appears relatively uniform in all directions today. Imagine stretching a crumpled piece of paper. As you pull it taut, the wrinkles become less noticeable. During inflation, the universe cooled down and energy began converting into particles like quarks and electrons, the building blocks of matter. This era was a flurry of particle creation and annihilation, a cosmic dance of energy transforming into matter. Section 4. From particles to galaxies, the universe takes shape. As the universe continued to expand and cool, the newly formed particles began to clump together under the influence of gravity. Over millions of years, these clumps grew larger and denser, eventually forming the first stars and galaxies. The early universe was filled with hydrogen and helium, the lightest elements. Inside the cores of stars, nuclear fusion reactions began, forging heavier elements like carbon, oxygen, and iron, the very elements that make up our planet and ourselves. These heavier elements were then scattered throughout space when massive stars exploded as supernovae, seeding the universe with the ingredients for planets and life itself. We are quite literally made of star stuff. Section 5. Echoes of the Big Bang Evidence and Unanswered Questions. The Big Bang Theory is not just a compelling story, it's supported by a wealth of scientific evidence. One crucial piece of evidence is the Cosmic Microwave Background Radiation, or CMB. The CMB is like a faint afterglow of the Big Bang, a faint echo of the early universe. It's a faint microwave signal that permeates all of space, and its properties match the predictions of the Big Bang Theory. Another piece of evidence is the observed redshift of distant galaxies. This redshift indicates that galaxies are moving away from us, and the farther away they are, the faster they seem to be receding. This observation supports the idea of an expanding universe. While the Big Bang Theory is remarkably successful in explaining many aspects of our universe, it still leaves some unanswered questions. What caused the Big Bang? What is the nature of dark matter and dark energy, which seem to make up the majority of the universe's mass and energy? The quest to understand the universe's origin and evolution is a journey of ongoing discovery. As we continue to explore the cosmos with ever more powerful telescopes and sophisticated theories, we move closer to unraveling the mysteries of our cosmic origins.